In this video, I'm going to find the divergence and curl of the vector field f, which is equals to 2x cubed y to the power 4 plus xi plus 2x to the power 4 y cubed plus yj. So given that vector field there, that one is a two-dimensional, it just has an I and a j. Given a vector field f, the divergence of the vector field f is grad dot f. In this case, this vector field that we are given is two-dimensional. So the form of the grad that we have to use there is the two-dimensional one, which is grad is equals to partial derivative with respect to xi plus partial derivative with respect to yj. So using this formula that we have, I take the dot product of the grad and our given vector field f. And when you are taking the dot product of two vectors, we multiply the corresponding elements. So I look at the elements where we have the I. So we have the partial derivative with respect to x of 2x cubed y to the power 4 plus x. So I'll write it down. The partial derivative with respect to x of 2x cubed multiplied by y to the power 4 plus x. Then go on and look at the elements where we have the j. So we have the partial derivative with respect to y of 2x to the power 4 multiplied by y cubed plus y. So I'll write it down there, this partial derivative. The next step, I'll go on and evaluate this partial derivative here. So for this partial derivative, we are differentiating with respect to x, but treating y as if it's a constant. And the result that we get there is 6x squared y to the power 4 plus 1. Then go on and evaluate this partial derivative with respect to y. Differentiate with respect to y, but treat x as if it's a constant. So what we would have there, the result is 6x to the power 4 multiplied by y squared plus 1. But I can combine the ones here so that we have 1 plus 1 to give us a 2. So we have 6x squared multiplied by y to the power 4 plus 6x to the power 4 multiplied by y squared plus 2. So what we are having there is the divergence of the given vector field there is 6x squared multiplied by y to the power 4 plus 6x to the power 4 y squared plus 2. I now move on to finding the curl of the given vector field. Given a vector field f, the curl of that vector field by definition is the cross product of grad and f. When you are now taking the cross product, the grad that we would use is the one that is three-dimensional, just because when you need to take the determinant, we take the determinant of a square matrix. So for us to make a square matrix, we would have to use the grad, which is the k. So we would have our grad is equals to partial derivative with respect to xi plus partial derivative with respect to yj plus partial derivative with respect to zk. So I go on and evaluate that cross product. So it would be the determinant of ijk, partial derivative with respect to x, partial derivative with respect to y, partial derivative with respect to z. Then the components of the f, it has the I, then the j. It does not have a z component, that's why I put a 0 here. So I will now go on and evaluate that determinant. And to evaluate that determinant, I'm going to use the first row. So what I'll do, I'll close the row and the column containing the first element, the I there, and using the array of positive, negative, the I is sitting on a positive. So it will be I multiplied by the determinant of the uncovered elements. So the determinant of the uncovered elements there, that's the determinant of a 2 by 2 matrix. So we'll take the partial derivative with respect to y of 0, then the partial derivative with respect to z of 2x to the power 4 y cubed plus y. So I will write it down there, the partial derivative with respect to y of 0 minus the partial derivative with respect to z of 2x to the power 4 y cubed plus y I. Then I go on to the next part. We are now looking at the j. So I close the row and the column containing the j. Then take the determinant of the uncovered elements. So the uncovered elements there will be having a 2 by 2 matrix. So we have this part take the partial derivative of 0 there, then this part take the partial derivative with respect to z. And the j, when you are looking at the array of positive, negative, it's sitting on a negative. So it will be minus the partial derivative with respect to x of 0 minus the partial derivative with respect to z of 2x squared y to the power 4 plus xj. I then move on to the last element there, the k. So I close the row and the column containing the k, and the k is sitting on a positive. So I will then go on and evaluate the determinant of the uncovered elements. So we'll be looking at the partial derivative with respect to x of 2x to the power 4 multiplied by y cubed plus y. Then minus the partial derivative with respect to y of 2x cubed multiplied by y to the power 4 plus x. So I'll write it down there, plus the partial derivative with respect to x of 2x to the power 4 y cubed plus y minus the partial derivative with respect to y of 2x cubed y to the power 4 plus x k. We are having a plus just because the k there is sitting on a positive. I'll now go on and evaluate the partial derivatives for each of the components I, j, k. So I'll start by this one there, where we have the I, and the result that we get there is a 0. Then for the next one, evaluate these partial derivatives where we have the j there, and we would have the partial derivative of 0 with respect to x is a 0, and the partial derivative of 2x cubed y to the power 4 plus x with respect to z. We are treating the other variables there as constants, so our result there will be 0. So it will be minus 0j. And then I'll go on and look at the component where we have the k, evaluate these partial derivatives here. So when you differentiate 2x to the power 4 y cubed plus y with respect to x, treating y as if it's a constant, the result that we get there is 8x cubed y cubed. Then on this other part here, we are differentiating with respect to y, but treating x as if it's a constant, and the result that we get there is 8x cubed y cubed. So for the highlighted part, it will simplify to 8x cubed y cubed minus 8x cubed y cubed k. So that's what we are having. But if we look at this part, 8x cubed y cubed minus 8x cubed y cubed, it is going to give us a 0. So this highlighted part there is a 0. So if it's a 0, our k will simplify to 0i minus 0j plus 0k. So that's what we are having there. This given vector field is divergence 6x squared multiplied by y to the power 4 plus 6x to the power 4 multiplied by y squared plus 2, and its curl is equals to the 0 vector. And if the curl is equals to the 0 vector, then the given vector field is said to be conservative. So what we are having here is a conservative vector field.